The human aspiration to conquer the sky. Since the dawn of humanity, we have looked up at the night sky, mesmerized by the countless stars shimmering above. The vastness of space, the distant celestial bodies, and the mysteries hidden beyond have always ignited our imagination. From ancient times, people have pondered fundamental questions. Who are we? Where do we fit in this immense cosmic landscape? These questions have driven humanity on a relentless pursuit to explore the universe, uncover its secrets, and push beyond the limits of what was once thought impossible. For centuries, humans relied solely on their eyes to observe the celestial sphere, recording patterns of the sun, moon, and stars. These observations laid the foundation for early astronomy, inspiring civilizations to create calendars, predict eclipses, and navigate vast oceans. Yet, it was only with the rise of science and technology that we began truly unraveling the mysteries of space. The journey from stargazing to stepping on celestial bodies has been long and fraught with challenges. It is a story of brilliant minds, groundbreaking discoveries, and immense risks. It is a saga of perseverance, courage, and ambition, one that transformed our understanding of the universe. So how did we get here? What were the crucial milestones in humanity's quest to reach the stars? This journey, spanning thousands of years, has been one of the greatest adventures in human history. Let us embark on this odyssey together, tracing our steps from the first observations of the night sky to the future of interstellar exploration. The astronomical revolution. When truth was challenged for over 1,000 years, the idea that Earth was the center of the universe remained unchallenged. Aristotle's geocentric model, perfected by Ptolemy in the 2nd century AD, was widely accepted as truth. It was embraced by scholars, institutions, and even religious authorities. To question it was to question the natural order of the cosmos. Yet, as time went on, cracks began to form in this long-standing belief. Copernicus and the heliocentric model. A silent revolution. In the 16th century, a Polish mathematician and astronomer, Nicholas Copernicus, dared to rethink the structure of the universe. He proposed a radical idea. The sun, not Earth, was the center of the cosmos. In his work De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, he argued that Earth and the other planets orbited the sun in a system that was far simpler and more logical than Ptolemy's geocentric model. However, Copernicus hesitated to publish his findings. He knew that such a claim would challenge centuries of established thought and could provoke backlash from religious institutions. It was only on his deathbed in 1543 that his book was finally released. Though his ideas did not gain immediate traction, they planted the seeds of a revolution that would soon shake the foundations of science and philosophy. Galileo Galilei, the scientist who defied the Church. Nearly a century later, Galileo Galilei took Copernicus' theory a step further. In 1609, he built one of the first telescopes, powerful enough to observe celestial objects in detail. What he saw shattered ancient beliefs. He discovered that the moon had mountains and craters, proving it was not a perfect celestial sphere, as Aristotle had claimed. He observed 4 moons orbiting Jupiter, demonstrating that not all celestial bodies revolved around Earth. He saw that Venus had phases, much like the moon, which was only possible if it orbited the sun, not Earth. Galileo's findings provided concrete evidence for the heliocentric model, but they also made him a target. The Catholic Church, which upheld the geocentric view as divine truth, saw his work as heretical. In 1633, Galileo was put on trial for heresy. Under threat of torture, he was forced to recant his beliefs and spent the rest of his life under house arrest. Yet, as legend has it, after his trial, he whispered the famous phrase, "Et per se muove," and yet it moves. Johannes Kepler and the laws of planetary motion. While Galileo battled with religious authorities, another scientist, Johannes Kepler, refined Copernicus' model even further. Using detailed observational data from Danish astronomer Tycho Brahe, Kepler formulated 3 laws of planetary motion that described how planets moved around the sun. Most importantly, he discovered that planets did not move in perfect circles, as previously thought, but in elliptical orbits. This realization brought the story of GNZ11, a journey through time. Among the billions of galaxies out there, one stands out, GNZ11. This galaxy is not just incredibly distant, It acts as a time machine that allows us to peer into the past. The light from GNZ11 left this galaxy 13.4 billion years ago. When you observe it through a telescope, you're not just looking at a faraway galaxy, you're gazing back in time to an era when the universe was only 400 million years old. However, there's a strange twist. The actual distance between GNZ11 and us today is not 13.4 billion light-years, but approximately 32 billion light-years. This is due to the universe's continuous expansion, stretching the space between us and the galaxy over time. The existence of GNZ11 raises many questions. If we have already detected a galaxy that is 13.4 billion years old, are there even older and more distant galaxies yet to be discovered? And more importantly, can we ever reach the ultimate boundary of the universe? Cosmic mysteries, adding suspense. We have discussed distances and sizes, but what about the deeper mysteries? Is the universe truly infinite, or is there an edge beyond which humanity has not yet ventured? An intriguing hypothesis suggests that if you travel far enough in one direction, you might return to your starting point, just like circumnavigating the Earth. This implies that the universe may have no physical edge, yet it might not be truly infinite. And here's an even more compelling question. Are we alone in the universe? With countless galaxies, each containing hundreds of billions of stars, and each star potentially hosting planets, what are the chances that life exists elsewhere? Could there be other civilizations out there, observing us just as we observe distant galaxies? Open-ended conclusion, challenging viewers to think. Science has brought us closer to some answers, yet the universe remains filled with countless unsolved mysteries. If the universe is truly infinite, could there be another version of you somewhere, pondering these very same questions? Some scientists believe in the multiverse theory, the idea that our universe is just one among an infinite number of parallel universes. If this is true, every decision you make could create a new reality where a different version of you exists, living an entirely different life. We may never fully understand what lies beyond the observable universe. But one thing is certain. Every time we look up at the night sky, we are not just seeing starlight, we are witnessing history, the stories of a vast universe waiting to be explored. Enhancing the experience with sound and visuals. A video about the universe should not only provide information, but also evoke a sense of adventure and mystery. The background music can start slowly, with soft, ambient tones, gradually building up to a crescendo when discussing the expansion of the universe or mind-blowing theories. By integrating CGI visuals of distant galaxies, scenes of space travel, and a compelling narrative voice, the video can do more than educate. It can make viewers feel as if they are embarking on a journey through the cosmos. And as the video concludes, leave the audience with one final question. If infinite possibilities exist, could there be another version of you, somewhere out there, asking the very same thing?